Going to solve a sample problem about statically indeterminate beams having two redundant. Here's the problem. Determine the reactions at the supports and then draw the shear and moment diagrams using letter A double integration method, letter B moment area method, and letter C superposition method with RB and RC as redundant. Assume the support at A is fixed and B and C are rollers. EI is constant. So in this video, I'm going to use double integration method. Uh, so first step is to use equilibrium equation, but let us first identify the reaction. So at A, fixed man. So we have RA vertical. Sa horizontal, considered na zero. Since ang external load na to, vertical tanan. So I have RA, assume na upward. And then MA, assume na counterclockwise. And then RB, assume to be upward as well as RC. So using equilibrium equation, let us start with summation of force vertical equal to zero. All forces directed upward, positive. So for the uniform load, we get the resultant. So the resultant is equal to the area of the load. So 3 times 25. So that's 75 keeps acting at the center of gravity. So we have this equation, RA plus RB plus RC upward minus downward 10 and 75 equal to 0. So simplify. Okay, this is our equation number 1. The other equation is summation of moment. You can sum up moment either at A, B, or C. Okay? For this one, let us sum up moment about C. Okay? And sign convention counterclockwise, positive. And we have this equation. For RA, it's negative since clockwise. So force times distance, 45. RB, it's clockwise also. Distance is 25. MA is counter, so positive. Ang 10 counterclockwise, so positive. 10 force times distance, 35. And then the last one, 75 keeps counterclockwise, so positive. Ang distance is 1/2 of 25. That's 12.5. And then we simplify. Okay. So this is our equation number 2. You'll notice na there are 4 unknowns, RA, MA, RB, and RC. But we only have 2 equations. Therefore, we need additional 2 equations here. So we'll get the 2 equations using double integration method. So we have this one, and we'll use makaulay. So we'll cut a section here, and then at a distance x from A, and then get the moment. Since we are analyzing the left side, so ang direction sa moment is counterclockwise. So, M equals, okay, pag equals na, meaning, clockwise moment is positive na since nakatranspose naman eh. Okay. Like RA, it's clockwise, so ma-positive na. Like originally negative man na equal to 0 and i-transpose ma-positive na. So RA times distance plus RB distance x minus 20. And then for moment, MA, we'll use this one. Distance sa M to the cutting section is x, but then with exponent na 0. And then 10, counter man, so minus na. No? Kaya ina-transpose man eh. Force, this distance, this is x minus 10. And then for the uniform load na nakat, the resultant is 3 times x minus 20. That's the resultant, this one. And ang distance niya is x minus 20, this one, x minus 20 over 2. So we simplify this term. We have this one. It's 1.5 times x minus 20 squared. And so apply double integration method. We integrate this one. We have the expression of slope. So RA, integral of x squared over 2, up to the last term. X minus 20 raised to 2. So integrate, that's cube over 3. So 1.5 over 3 is 0.5. And then integrate again, since double integration. So integrate again, we will have the expression of deflection. Okay. So pwede ra ma-check each term pag if there is something wrong with the integration. So after this, boundary conditions. So if you have makaulay, we only have C1 and C2. So typically we need to boundary conditions. Pero if you look at the problem, we have 4 boundary conditions. So at A, since fixed ni, the slope is 0, deflection is also 0 at A. At B, deflection is 0, and at C, deflection is 0. So we have 4 compatibility equations. We start with A, where slope is equal to 0. Now, if you look at this one, this is the expression of slope. So pag 0 ang slope, x equal to 0, 0 minus 20 is ma-neglect. This one, 0, 0 minus 10, ma-neglect. 0 minus 20, negative, ma-neglect also. Therefore, pag 0 tanan, it means C1 is 0. And then condition number 2. Condition number 2. At point A, where x equals 0, the deflection is equal to 0. So, looking at this equation, 0, x 0, 0 ma-neglect, 0, 0 minus 10 ma-neglect, 0 minus 20 ma-neglect, 0. Therefore, C2 equals 0. So, ang constants na to, C1 and C2 are both equal to 0. Now, we use the third boundary condition at B. So, at support B, at x equal to 20, the deflection is 0. So, this is the equation. 0, 20, 0, 20, okay, 20 minus 10, okay, 20 minus 20, 0. So we have this one, 0, RA over 6, 20 cube, minus MA over 2, 20 square, and then this one, minus 5/3, 20 minus 10, that's 10 cube. And then we simplify, we can multiply the equation by 6. or 3, pwede na 3 kay. Although 6 na yung 2 nga factor makancel sa ibabaw. Numerator. So, pwede ra na 3. I-multiply og 3. And then each term naman tayo 20 cube, 20 cube, 10 cube, 10 square, 20 square, 10 cube. The common here is 10. 10 raised to 2 kay squared raman. Or you can have this one. 3 over 200. Okay. So if you multiply this term sa equation, we have this one. 20 RA minus 3MA equal to 25. This is our third equation. And the fourth one is at point C, where the deflection is 0. So at x equal to 45, y is equal to 0. And using the same equation, we have this one. RA over 6, 45 cube, 45 minus 20, so 25 cube, 45, 45 minus 10, 35 cube, and this one, 20 minus, 45, 45 minus 20, you have 25. Combine this one, and then we can multiply the equation by this one, 24 over 25. Actually, it's sort of trial and error. No? So you can multiply the equation by a certain number, and then pag simplify, pag dili pa siya lowest term, then you can multiply it again by another number or divide. So we'll distribute these terms, all terms sa equation, and we have the simplified form. This is our fourth equation. So we have 4 equations now with 4 unknowns. So enough na na. So if we combine equation 2, 3, and 4, sa equation 2, ang unknowns niya RA, RB, and MA. And sa equation 3, RA and MA. Sa equation 4, RA, RB, and MC. So we can combine the 3. Wala may RC. RC is only involved sa equation 1. Pero sa 2, 3, and 4, walay RC. So we can combine the 3 equations. We have this one. This is our equation 2. And then equation 3, i-fit lang. And then equation number 4. So using your calculator, mode 5 or mode equation with 3 unknowns, then you can solve for RA, RB, and MA. So this is our RA. Negative means downward because the assumption is upward. So upward ang RA. But then pag solve, it's negative. So it means na downward. RB is positive, so as is na yun. As is, upward siya. And then ang moment is negative. It means na clockwise. Kaya counter man. Tapos nag-negative. So clockwise din. So after this, ang kulang na lang is RC. So from 1, nere, knowing RA and RB, you cannot determine RC. This is RA, RB, and RC equals 85. So RC is equal to 2001 over 64. Okay, so after this, we are now ready to draw the diagrams. Okay. So we can substitute the actual direction of the reactions. Like RA, it's negative, so it's downward. Ang MA is negative pod, and the assumed direction is counterclockwise. And nag-negative siya, so it means clockwise. And ang RB is positive, so sakto ang i-assume upward. And ang RC, positive sad, so sakto ni. So after this, you may draw the shear and moment diagrams. Okay. So here's our beam, and instead of fraction, we can substitute the value in decimal form, like this one. Okay. So it's 2465 over 512. It's 4.81445. MA 5175 over 128 is actually 40.4297. RB, do the same. You divide ang fraction, 58.5483, and then RC 31.26562. Okay, so we now plot the shear diagram. So at A, it's downward, so paubos siya, pababa. And then for this part, no load, so horizontal. And then na kay 10K na downward, so negative 4.81445 minus 10. We have negative 14.81445. And then for this part, no load, so horizontal. And then at B, you have this reaction upward. So negative 14.81445 plus 58.54883. That's 43. And then from B to C, uniformly distributed. And the shear diagram is straight line. The resultant is 75, 3 times 25. So it's 75 na negative. So it's 43.73438 minus 75. Okay, the result is 31.26562. And then at C, you have this upward reaction. Okay, so ma-close ang diagram. So next here is to draw the moment diagram. And you will notice na the graph crosses the x-axis, no? So we are going to locate this point. Okay. So let's denote this distance as x. So to solve for x, you can use ratio and proportion. No? Vertical over horizontal equals vertical over horizontal. Now this distance is 25 minus x. Okay, we have this one. Ratio and proportion. 43.73438 over x equals 31.2656562 over 25 minus x, this one. And we have x equal to 14.57813. So after this, we use area method pag-plot sa points. So at A, naatay reaction, naatay moment na 40.4297. And this is positive since na-follow niya ang the beam smiles na direction. So kung naka sa left side, left na support, and then clockwise yung movement, then the beam smile na sa positive. So from the moment diagram, natay upward na 40.4297. And then after this, you should lock this area. 4.81445 times 10. So 40 minus 48, that's negative 7 point something. And then after this, downward na sad ni 14.81445 times 10. And so we have this one, 155.8593. And then after this, you add this area, 1/2 base times height. The moment at this point is this one, 162.92344. And then after this, you subtract this area. Area sa triangle, 1/2 base. The base is 25 minus x. And then height na. Okay. So, nag-zero ang diagram, which means na ang value sa reactions are correct. So, I hope that you have learned something from this video. Now, I'm going to solve the same problem using the other two methods. So, you can watch those videos as well. So, thank you for watching, and I hope that you have learned something. Thank you.